This shows a model of what may be causing these cryovolcanoes, and it's a lot like what you see in diagrams if you go to Yellowstone. You see hot rock underneath due to tidal heating of the planet, of the moon, caused by the gravity of Saturn, and it heats up pressurized liquid, which then is vented to the surface, and this is just a cartoon also of the south area, which then it just so happens that the thickness of this water layer is the thickest. And it was interesting that how they first determined that there was actually water down here, and it again had to do with a trick, which is they measure the wobble as Saturn, as it orbits Saturn, and they determined that because of the wobble, the entire icy crust must be detached from the core. And they measure the amount of wobble, and it implies that the ocean is 16 to 19 miles deep. And so comparison to only 5. There's lots of water underneath the surface here, and of course it's venting. And it's venting interesting stuff. And so these are measurements Cassini has made of the various carbon compounds. This doesn't identify what they are, it just identifies their atomic number as they get up here. These are the number of the mass, essentially protons beyond 1. And so there's per charged particle. And this gives you a little more detail in this cartoon of what they are. Simple organics, carbon monoxide, complex organics, carbon dioxide, water vapor, methane. And and so this just shows what I already mentioned already. Enceladus is responsible for this this E ring, and this is a picture of Enceladus as it's going through, and it's going through the E ring in more detail. And this is about the end. So these are all of Cassini's orbits between 2004 and 2017. So it was a busy boy. And I'm not going to talk about its ending. I think I'll postpone that. I don't even have it here, so I can't. But I thought I'd end with this one picture, because this is what Cassini saw when it first approached Saturn in 2004. This is somewhere in the middle, and this is kind of what it saw at the end. And it's all because of the fact that 13 years is a significant fraction of Saturn's orbit around the Sun, so it's different parts of it are illuminated during different over that 13-year period. Okay, that's it.
Questions for Mike?
A lot of material.
Jupiter, I think you said the surface of that was measured at 1 bar pressure.
They sort of defined that at the top. That's all.
So is that where they measured the orbital period?
Yeah, that's right. They measured. Yeah, and the orbital period also varies with latitude. The top, the polar area is slightly different than the equator, but the down. But low, this motion stops deep inside, 3,000 kilometers down. There's no motion at all. Yeah. Well, the planet is still revolving, but the motion of the atmosphere has stopped. Within the planet, the motion has stopped. The planet is still, of course, rotating. Okay, but there's not internal motion. Yeah.
Yes, with regard to Jupiter and the 80-some moons eccentric
Yeah.
orbits, have any collisions been observed or predicted?
They certainly could occur. It's been 4 billion years, so there's probably a lot of them have cleaned themselves out. I'm sure it was much more chaotic at one point. Yeah. Yeah.
In planning for mining in space, are these planets?
Well, not these gas giants. You can't mine a gas giant unless you want.
Figure out a way to do it.
Well, there's not much in it either. It's mostly hydrogen.
Well, the helium.
Well, yeah, the helium is dissolved and it's heavy, so it's sunk way down inside. There's not much helium on the surface. Yeah. Yeah. So I don't think you're going to find much of interest to mine. Mars and the terrestrial planets could be, and maybe the asteroids. Yeah, because the talk I'm going to give is going to, maybe I'll go back and fill in some gaps here. It's going to talk about the asteroid mission, the Dawn asteroid mission. So that's another mission that is still going on. It's almost over. But Ceres and Vesta, and then there's also the mission, the Rosetta mission that the European Space Agency did to the comet. So we're going to talk about that. And updates. There's more information. I'm not sure. All of you probably attended the January talk on Mars and Pluto, but there's more information there, so I'm going to talk some about that. So, yeah. Anyway, I got that up. Yep. Yes.
You didn't talk about any nitrogen on Jupiter, or what's with nitrogen? Why not?
Why not? Yeah, that's a good question. There is very little nitrogen on. You mentioned that the Titan, which is a solid body, it has a nitrogen atmosphere, but liquid nitrogen. What temperature is liquid nitrogen? It's pretty cold though. It might, whether it would be a liquid at the temperature of the surface well, you see, of course, it gets down too. So I don't know if nitrogen would exist. That's a good question. But there's apparently very little of it. So.
Repeat all the questions.
Yeah. Okay. Yeah, the question was, is there any nitrogen on Jupiter? And the answer is there seems to be very little. But the question is, why is that? Yeah. I have to look at the temperature. Nitrogen, I think, is 77 degrees Kelvin where it becomes liquid, and 77 Kelvin is colder than the certainly at the surface. So it would be a gas, for sure it would be a gas on the surface of both planets.
Have to do with helium being the product of hydrogen.
Well, you see, helium and hydrogen are primordial elements that existed at the Big Bang, and so Jupiter is thought to be a failed star. That it has almost the right ratio of helium to hydrogen as a star, as the Sun does too. So it's very similar, and that's at the primordial ratio, except that it's slightly less because some of the helium gets dissolved, and so it's not quite as it's lower than the solar amount, but but that's what. Now Saturn's a different story, but Jupiter is thought to be a failed star.
Mike, you implied earlier that the orbital positions of Jupiter and Saturn have been fixed since the dawn of time.
No, they aren't actually. No, they aren't.
Switch places.
I didn't. No, I don't think I said where they were originally. I think there's some discussion that Jupiter might have actually been much closer to at some point closer in, and then moved out. I didn't talk about the evolution of its orbit, but it's certainly the orbits. The whole solar system was very chaotic back in the first billion years because the sun was forming, and then the planets were forming, and collisions occurred all the time, and it would not have been a good time.
The angle of the axis looked fairly close to what the Earth's angle.
What's that?
The angle of the axis.
Yeah.
One of the pictures looked fairly close.
Yeah, Jupiter. Yeah, Saturn is almost the same as Earth. It's 26 degrees, and Earth is 23. Jupiter is 3. Jupiter almost is not tilted at all, so there's almost no seasons on Jupiter. But Saturn has big seasons. Yeah, I have one more. If there's no more questions, I want to just mention that. Yeah. Okay. So this has nothing to do with this talk, but I just want to make you aware of the fact that there's a program that's going to occur this Saturday in the village at the Walk Hall, and it's going to